Again, I just want to remind you, my name is Ron Bannon, and my email address is this: B as in boy, the @ symbol, nnon.us. And again, if you've been looking at the document along with me, working on the problem sets, good for you. If you got to this page over here, 1433, good for you. It's a long document. Um, it's a draft mode. So, roughly 2,500 pages long. It's a long document. The key is, though, if you think you see something and you want to say something to me, email me. If I'm not overwhelmed, I will get back to you. All right? But let me read this to you. This is number 11, and we're working through the problem set. It says the sum of the first 8 terms of a decreasing geometric progression is to the sum to infinity as 16 is to 25. So I'm going to write down S8. And what's that going to be? Well, I don't know, but I do know this. I know it's A times 1 minus R to the 8th. You know what? I'm jamming that in there too much. Let me start again. So S8 is going to be A. This is some formula that we've known from prior sections. 1 minus R to the 8th over 1 minus R. And then they also talk about the infinite sum. What's that going to be? A times 1 over 1 minus R. All right, now what do they say? They give me this like ratio thing. So the sum of the first 8 terms of a decreasing geometric progression is to the sum to infinity as 16 is to 25. So write that down. 16 to 25 is the same thing as like saying S8. Let's write that down. That's going to be A times 1 minus R to the 8th over 1 minus R. And the infinite one is going to be A times 1 over 1 minus R. All right? Now, by the way, that looks pretty complicated, but I do know one thing. A's are going to cancel, right? Non-zero A. And then I'm going to multiply top and bottom by 1 minus R. And then I get something like this. 16 over 25 equals, and I got to be careful here, it would just equal 1 minus R to the 8th power. Oh boy, that looks tough. It's doable though. So I'm going to say R to the 8th is going to be 1 minus 16 over 25. Well, let's do this. And what do you get over here? Well, it's going to be 25 over 25 minus 16 over 25. So you're going to get R8 equals, let's see, 25 minus 16 is going to be 9 over 25. All right? Well, you know what? I guess I got to do something here, don't I? So R could be a plus or minus sign. And I'm starting to notice this is really 3 squared, 5 squared. So, I'm going to write it down a little simpler than this. I'm going to write it as a 4th root problem, right? Because, 2 goes into 8 4 times. I'm taking the 8th root of both sides, by the way. And that would be 3/5. All right? Now, by the way, someone says, is that my answer? I don't know. I got to go back and read it, see what they're looking for. Oh, find the ratio. So before I do anything, I want to point out, they say of a decreasing geometric regression. So I want to point out if R is, I want to point out, if R is a positive number, and I'm seeing that over there, if R is a positive number. So if R is greater than, let me write this over here. And what I mean, R is also hope you realize is a fraction. It's got to be for having an infinite sum. So I hope you realize that the absolute value of R, regardless, is a fractional number. Let's talk about this. So A, right? And then the next one, if I multiply by let me see, the sum of the first 8 terms of decreasing geometric progression is the sum of the infinity 16 and 25. Find the ratio. AR, well, that certainly would decrease, right? The problem, though, is the other one. If I did the other one, what would happen? It's not decreasing. And why is that? It's alternating between positives and negatives. So I cannot use this here. So the answer is, again, if r were negative, it would alternate. R is the fourth root of 3/5. That's the only answer. Is that listed for me? It sure is. And again, why is that? If r were negative, the series would go back and forth, alternating, alternating, alternating. In other words, some numbers would be bigger than the others as we go down the list. All right? Thank you.